Good afternoon and welcome to the AHRI Safe Refrigerant Transition Task Force webinar. We're just going to wait for a minute for other people to join. It looks like our numbers are starting to level off. So again, we just want to welcome you to the AHRI Safe Refrigerant Transition Task Force, along with the UL and Fire Safety Research Institute, FSRI. My name is Helen Walter-Terranoni, and I'm the Vice President of Regulatory Affairs at the Air Conditioning, Heating, and Refrigeration Institute. You can go to the next slide, Mary. You can keep clicking through, Mary. These are just our terms of use and just some background information on the Safe Refrigerant Transition Task Force. These will be in slides that are available on our website. This afternoon, we're going to talk with you a little bit about some things happening on the regulatory front for refrigerants, as well as some background about a very interesting project that I think you'll want to hear about, the Air Conditioning, Heating, and Refrigeration Institute, AHRI, Project 8028, as well as some project deliverables and next steps. Mary, thank you. I'd like to introduce to you Kathy Stacia. She's a fire protection engineer at the Office of Illinois State Fire Marshal, and she's also a retired firefighter. And she not only is a retired firefighter, but also paramedic and firefighter inspector for Des Plaines, Illinois Fire Department, a former member of that fire department hazardous materials response team. She also serves on several technical code standards committees and codes committees for NFPA, as well as the CANINA and the UL STP working groups for UL 60335-2-40 and 89. She's also a certified safety professional and a member of NFPA, SFPE, AHRI, and CANINA. And she also does some training, which she didn't take credit for. You can go to the next slide, Mary, thank you. Chief Bill Offerman, Chief of the Elwood Fire Protection District, joined the fire service in 1981. He and has been with the Fire Protection District since 1995. He's a director of the Illinois Firefighters Association. He's also the Illinois Director of the National Volunteer Fire Council, Mayor of Village of Elwood from 2009 to 17. And if he's not busy enough with all of that, he has served with the Will County Board of Health, worked as an adjunct professor for Loyola University, and has a Master's of Science in Public Safety Administration. Dick Lord is with us today. He's got 48 years of experience in commercial air conditioning design and application. He's the chair of the AHRI Advanced Energy Standards, as well as the vice chair of AHRI 90.1, a member of several other AHRI committees, and the Systems Steering Committee at AHRI, CSA HVAC Standards Committee, as well as other CSA committees. He is a member of the Alliance to Save Energy Systems Initiative and Montreal Protocol Working Group on Energy Efficiency, as well as the Energy Alliance, and advisor from AHRI 15 and 15.2, and an AHRI fellow. We also welcome Steve Kerber, who's the Vice President of Research and Director at UL FSRI. He leads the Fire Safety Research Team, addressing fire safety risks and dangers to reduce death, injury, and loss from fire. 13 years with the fire service, most of which at the College Park Fire Department in Maryland, where he served at ranks up through Deputy Chief. He was an honorary battalion chief at the Fire Department of New York and 2014 International Society of Fire Service Instructors and Fire Engineering George D. Post Instructor of the Year. Also received the President's Award of Distinction for the 2019 Metropolitan Fire Chiefs. Fellow Society of Fire Protection Engineers, as well as Bachelor's and Master's in Fire Protection Engineering from the University of Maryland, and a PhD from Lund University in Sweden. Thank you, Mary. So we just want to firstly talk to you about refrigeration regulations in general. Since the early days of mechanical refrigeration, there has been a selection of refrigerants that has changed to adapt to scientific findings and regulatory requirements, balancing safety and environmental sustainability. So now I just want to talk with you a little bit about refrigerant regulations. So refrigerants are approved by the Environmental Protection Agency only after an analysis of safety, toxicity, flammability, and other environmental factors. Also, we're going to talk a little bit about the 2020 American Innovation and Manufacturing Act, signed into law on December 27th last year by President Trump, which requires a transition of current refrigerants. Today, in addition, it would be important to note that 9 states already have individual refrigerant regulation programs requiring transitions of refrigerants. In summary, current refrigerants are being replaced by alternatives, such as A2L, lower flammability, and traditional refrigerants with a smaller environmental footprint. So the EPA I mentioned earlier looks at refrigerants from the perspective of safety, flammability, toxicity, and environmental footprint, and then determines their suitability for use. The EPA Significant New Alternatives Policy Program, the SNAP program, allows flammable refrigerants as long as the safety standards are adhered to. So for example, residential and light commercial air conditioning refrigerants have been allowed, are just now allowed this month for larger charge sizes. For smaller charge sizes, they've been allowed since 2015, for chillers since 2012, then for self-contained refrigeration, also for 2012, and auto air conditioning since 2011. On the other hand side of things, there are mandates in some cases from a regulatory perspective to transition away from older refrigerants or current refrigerants into refrigerants that will likely be flammable. So today, plug-in appliances, so like refrigerators in your home, window units that you might purchase at a big box store, and light-duty vehicles all contain A2L refrigerants or A3 refrigerants now. In 2024, we anticipate that commercial refrigeration equipment in Washington State will be using a flammable refrigerant, as will chillers. In Washington State and 9 other states, residential and light commercial air conditioning equipment will likely transition across the nation in 2025. And probably in 2026, remaining commercial refrigeration equipment will transition away from current refrigerants, including some A2L or A3 flammable refrigerants. So it's important to quickly just think about, what's the same, what are the hazards of the current refrigerants? So current refrigerants, if there's a combustion that takes place, if they're exposed to fire, any fluorinated refrigerant will combust to a hydrogen fluoride gas, which would become a hydrogen fluoride acid if water is sprayed on it. Oxygen deprivation is possible in tight and enclosed spaces. So like a crawl space might be a possibility for enclosed space, or even a machine room for a large charge size. Frostbite is also possible with a quick release of a liquid refrigerant, and personal protective equipment, PPE, including SCBA, is a necessary part of firefighting. And the tactical considerations for firefighters at this link will provide you with much, much more information than we will get into today. So what's the difference? What's new with these new refrigerants? The refrigerant transition will require lower and higher flammability refrigerants to be used to meet regulations. These lower flammability or A2L refrigerants, as you may hear about them today, they're characterized as having a low flame speed and a low heat of combustion. Higher flammability refrigerants include hydrocarbons such as propane and butane that have high flame speeds and high heat of combustion. So AHRI, the Department of Energy, California Air Resources Board, the American Society of Heating, Refrigeration, Air Conditioning Engineers have spent well over $7 million in next generation refrigerant research. They've looked at features such as the validation and mitigation of safety standards. They've looked at leak detection technology, ignition byproducts, ignition properties, flammable refrigerant product risk assessments, as well as other features of ignition sources, for example, and other research around the safe use of flammable refrigerants. So what was missing? Why did we move forward with this project that we're talking about, this 8028 project? So Refrigerants and Firefighter Tactical Considerations is the first project of its kind related to fire impinging on refrigerants and equipment to provide practical information for first responders for the purposes of developing training. Although there's been this considerable body of industry research, it's been focused on largely on A2Ls with some research on A3s. This piece of the puzzle was missing. So what does this change mean for the fire service? And what are these A2L refrigerants and how do they compare with the substances that they're replacing? Some of these were questions that the fire service had. And I just want to turn to some of our panelists today. So we have with us Kathy Stacia and Chief Offerman, as well as Steve Kerber and Dick Lord. And I just wanted to kind of open the floor for you to talk to us a little bit about what you saw and what you needed to know to be comfortable with this transition. Kathy, is it okay if I start with you and kind of ask you, what were you looking for? What kind of information was missing for you?
Well, A2Ls was a new substance for us. It was a new gas, and we were unsure on how it was going to respond in a fire. If it was exposed to fire, if the equipment was exposed to fire, if there was a leak, if something that we did during, maybe fighting the fire or overhaul, would that cause, we didn't know the extent of the problems. And so that was our concern. What was going to be the effect on firefighting as far as this new substance? We were definitely getting different stories from different people as to that this was highly flammable or not flammable. So it was really good that we all got together with AHRI and UL, because this really helped to kind of bring everything together and kind of calm us down a bit. But that was the main thing. We want the fire service to be prepared, to know what to do, how to approach equipment that will have A2Ls or just flammable refrigerants.
Thank you, Kathy. That's very helpful. And Mary, you can probably go to the next slide. And so I think there was kind of an exploration around what was needed from the fire service perspective, and tried to put together some test scenarios to replicate some conditions that might be encountered when responding to incident involving refrigerants. And we'll talk a little bit more about those here in a minute. Mary, if you could go to the next slide. So these are the organizations and collaborators that work together to develop these scenarios. And then we're just going to go to the next slide, Mary, and then maybe we'll open it up again for the panel to kind of talk through this a little bit. So the fire service had several requests and wanted to look at a couple of different scenarios and better understand things. Bill, if you don't mind talking a little bit about what you were hoping to see, and Steve, maybe what you all were hoping to see in some of these, in some of this work, that would be very helpful.
Thanks, Ellen. When I first found out about the flammable refrigerants, we were concerned that this was going to react similar to propane. So we were anticipating a much higher level of fire spread and possible explosion in residential situations, commercial situations. It was something that we did not see through the testing process. So it was quite the surprise to not have that situation. However, the toxic levels of the toxicity, I should say, the hydrofluoric acid that was developed was a bit of a surprise as well. We were not aware of that. It really wasn't much of a change from the existing refrigerants. However, we were not aware that it was there to begin with. So now that we're putting together the training to make sure everybody's aware of it and make sure that they keep their gear on their air packs, I think it's gonna be great for the fire service to at least catch up to where we need to be.
Steve, is there anything you'd like to add?
Absolutely, and I think for a lot of the participants here that don't have the fire service background or fire service knowledge, it's important that to understand that the fire services workplace is very complex. The amount of hazards are endless. Bill's response area, for an example, I mean, he's just getting back from an overturned tanker. He probably had an industrial fire today in his response area. The need to know all these things is really important. And one of the main things that we do at the UL Firefighter Safety Research Institute is we study the fire services workplace. And for most of you, this is where you live, this is where you work, but this is where the fire service needs to go to work. And it's important that we know how fire grows, how fire spreads, the impacts of their tactics, something as simple as opening a door or breaking a window, or changes in building practices, changes in building materials. All of these things can be found in structures and during fire service responses, and it's important that we understand their impact. And as Kathy said, it's really about the more the fire service knows about what they can encounter, the more effective they can be at saving lives, operating effectively, and ultimately being safe themselves. And that rationale that we've applied of doing research with the fire service over the last decade or so applies to refrigerants here. So it's really important that we got everybody together, understood the gaps, and were able to address them together.
Great, thank you, Steve. I already have a question from the participants. We've got a question around what overhaul is in firefighting activity, and I don't know if maybe Kathy or Bill want to talk about what that means.
It's after the fire is out, and we're it's a multitude of things. We're checking to make sure there's no spread of the fire. We're trying to prevent more damage from smoke of the inside, and we're not necessarily cleaning up, but we're just making sure that the scene is safe and that we can leave it, and that we're not going to get any rekindles. Sometimes we have to open up walls, move furniture, just make sure that everything is set so that we can leave the scene. Fire investigators can come in, or we can turn it over to a board up company.
Thank you, Kathy. I really appreciate that. And then, Dick, you were on the technical team that kind of helped to put these, kind of translate these needs from a scenario perspective into kind of the technical nitty-gritty details. Is there anything that you can kind of, provide information you provide us with around how that work was done and kind of your thoughts around that in general?
Yeah, sure. I'd be glad to talk about that. I mean, we've been looking at these refrigerants for a long time. It goes back to 2010 when we first started to realize that we're going to have to change refrigerants for environmental purposes and global warming. So we came up with the A2L designation, which was, lower flammability. But like most people, when they hear the word flammable, they think of propane. And a lot of people just really didn't understand refrigerants because we've kind of been complacent in our use of refrigerants. So we talk about A1 refrigerants as non-flammable refrigerants. They're really not non-flammable, they're low flame spread. So this was an interesting project. So we got to take a lot of the work that we had done as manufacturers, as industry, to try and understand A2L and then apply it to what's in a real building. And, we don't know a lot about building fires or how building fires progress. So I think it was a really good exercise where we kind of outlined what we wanted for testing, but then during the testing, we said, hey, what about this? And what about this approach? And, Steve and Bill and the other fire services guys gave us some good input. And then we balance it off and say, well, this is the way we'll apply the units. This is how they would be mounted, how they'd be configured. This would be the charge level. So I think it was a really good collaboration. And I think we came out with a good result. We changed it as we went through the testing, but I think we all learned a lot from this testing.
Bill or Kathy or Steve, if you want to add anything, you're more than welcome to. I will say this, I've never been so jealous of not being allowed to travel in my life. This all happened during the pandemic, and people gave a lot of their time wearing a mask, watching all these scenarios take place. It was a lot of work and a lot of time devoted to this. So I don't know if Bill or Kathy or Steve have anything they'd like to add around this before we kind of dive in and talk a little bit more about the scenarios.
Just build on what Dick said. I mean, this couldn't happen without partnerships. And coming from the fire research community, I didn't know much about refrigerants. I know the units and maybe some of the mechanical engineering involved, but really having Dick and others and Helen to rely on to fill in those gaps, to round out the picture, really allowed us to understand how we marry what the fire service might see to what is possible, what is likely, and then ultimately test those bounds to make sure that people like Bill and Kathy had the answers that they were looking for.
And it took a lot of education on AHRI and the refrigerant industry for us, because, I mean, when I first started becoming involved in this, I mean, it's like asking me to code a computer. What are you talking about? M1, M3, you know? So it's been a large learning curve, and the refrigeration industry has been very patient with us.
Well, I think vice versa, Kathy. I mean, you saw one of the first questions in this webinar was what's an overhaul. So thank you for educating folks, you know, that are watching this that are not familiar with these terms, and much less the kind of work you do. Like Steve said, Chief Offerman just came from a situation, and I guess you just never know what's going to happen out there. So, Chief Offerman, did you want to say something?
Yeah, as they said, this was a great collaboration between the refrigeration industry, between your engineers, Underwriters Laboratory, and also the fire service, to be able to get our input, to test what we wanted to see, to understand what we were going to come in to and have to react to, and what the results would be. So thank you very much for that opportunity. It was great to work with everybody, but I'm very pleased that everybody had their input, and I think we've got some great results from it.
And to plug my other colleagues from UL, certainly what tests can we run? How can we do it safely? What can we burn? How much, under what conditions, what measurements can we make? All of that is a really complex component of this that ultimately did allow us to get the answers that we did.
Steve, you took the words, and I was just going to say thank you to them. I know they're not on this panel, but thanks to them, and thanks to Bill and other folks that attended, you know, all those sessions, Dick and others that sat through all that very long days, and all the work that went into this. I think that a really nice product has come out of it. Mary, you can, before we just keep congratulating everybody in a circle, we probably should move along to the next slide and let Steve talk a little bit about these scenarios.
Yeah, thanks, Helen. So I'm going to briefly go through the scenarios that were covered in the project. So essentially, once everybody got together, once all the stakeholders agreed on what the questions were, we all had to figure out how are we going to get these answers. And that wound up showing itself essentially as a series of test scenarios, of which many variables were examined, many iterations were done, many different refrigerants were examined. And ultimately, this becomes the backbone of the online training course I will talk about. That's one of the ultimate outputs of this project. So scenario one was conducted to collect comparative data on selected A1 and A2L refrigerants, and to really look at quantifying what they contributed to the heat and the gases that are generated during a fire. So as you can see in the picture here, simulating a refrigerant leak blowing across a fire that is already existing to see what it contributes to the ultimate heat release rate, as well as other measurement components, whether it was HF concentration, temperature measurements, heat release rate, were all important. We saw this as a nice side-by-side comparison, something that's been effective before during other experiments. If the fire service can see one right next to the other, that provides a pretty good visual indication as to how they're different. And that's what we were going for in experiment or in scenario one. Scenario 2 got a lot closer to the fire service's reality. So this was conducted to investigate the hazards faced by firefighters that would be advancing down a hallway towards a room fire, and how would the fire dynamics change if we were to have a catastrophic leak, either from outside the unit or from inside the unit. So both of those scenarios were examined, and ultimately the measurements here are looking at if a hose line is being advanced, the room of fire, let's say, is a basement storage room at the end of the hallway there. If they were on their way, not able to put water on the fire yet, what would the resulting fire dynamics be should that leak occur, is what we were going for in scenario 2. Next slide. So scenario 3, ultimately the team decided didn't need to be run. This was really set up as an optional scenario based on what we learned in scenario 2. So the difference here was going to be, instead of forcing the leak, a leak would be created due to the fire conditions. It would essentially be set up like an actual unit. But since the forced leak, both inside and outside the unit, really didn't create more hazardous conditions in the corridor area of what we were focused on from a fire service concern perspective, everybody got together. So it was the UL staff, the AHRI staff, and the fire service observers, and felt that there's really no sense in replicating the same thing again. Let's put our efforts and resources elsewhere as we move forward. So we did more of scenario 2 maybe than we thought, but ultimately didn't have to run scenario 3. For scenario 4, our objective was to assess the hazards in a room fire during overhaul activity if the firefighters' actions result in a catastrophic refrigerant leak. So they break the line. Kathy was explaining overhaul very well, but overhaul tends to be incredibly chaotic. Sometimes it's in limited visibility. It often involves tools, a lot of chopping, cutting, pulling, pushing, all of those things to make sure that the fire is not extending further into void spaces and making sure it's completely out. Could easily result in a line being compromised or crushed or disconnected or whatever the case is. So we wanted to look at that, and what you see in the picture there is we also made the assumption that there was still an ignition source available in the room nearby. So could we get some localized concentration of refrigerant that would result in a different outcome as an A2L versus an A1, was the reason for scenario 4. And then next slide. Scenario 5, this is really where, again, everyone came together and said, well, we didn't really see any pooling in experiment 4. Is it possible to force it so that we can get a sense of what flame spread rate really looks like? It should the pooled refrigerant ignite, how quickly does that fire spread? Does the fire service have time to react? So in order to get this particular condition, we had to pretty much replicate a very slow leak into a very tightly sealed room to get the quantities that we needed to hit those flammable limits with very little air movement or ventilation in the room. And this is really, we had to extend beyond what is probable here and to put all of these conditions together, but we really wanted to provide that visual observation to the fire service so they can see that how the difference between A1 and A2L refrigerants appear when ignited. And we have a still shot here that in itself is very interesting, but I think this alone should be a reason to go to the online course to watch a video of this particular scenario. It's very interesting how the fire moves across the room, what I would consider relatively slowly.
Steve, maybe I could ask you to pause for a second. I understand that this, I was at home calling in, because of the pandemic, you all in the, kind of in the room kind of developed this on the fly. And, there were some specific things that, that Chief Offerman and others wanted to see. And so Chief Offerman, I don't know if you maybe want to speak a little bit to that. And Dick, you were, of course, there, trying to work through this and develop this scenario. And, we tried to kind of, from the phone, help to come up with something that was, would produce the results that you wanted so you could see things, while kind of recognizing that we were stretching our imaginations a little bit with this scenario. So Chief Offerman, I don't know if you want to speak to this a little bit, or Dick?
Yeah, I'll speak to it. We were very interested to see if we could get the refrigerant into a flammable range in a confined area to see if we were going to have some type of an explosion. So we worked very hard to try to achieve that, and we did achieve a slow, sweeping, moving flame, but never the detonation, for lack of a better term, that we'd anticipated. So this was something that was very important to us, and you guys made it happen. We appreciate that. But we had to be at a specific level. We had to keep everything slowed way down, very calm, in order to pool enough into an area to get it into a flammable range, and then provided multiple ignition sources just to try to get this to ignite. It was actually very difficult. But I'm glad we did it. Now we saw what took place with it. And as Stephen said, I would encourage everybody to attend the seminar on this and watch what each one of these experiments are. Now you'll know exactly how it behaves.
Yeah, maybe add a little what Bill said is, one of the things that's characteristic of most refrigerants that we look at, they're heavier than air. So there was concern, and I understand where the fire marshals were coming from, is, well, it's heavier than air, it's going to settle on the floor. Do I plant a flammable mass? Do I introduce an ignition source in there during the overhaul? So we tried to create this, and there'd been a lot of information around the industry that this will result in a defragration event with an explosion. And we'd done a lot of work in the industry and know these refrigerants are difficult to ignite. It takes really high concentrations in the 13–14%. So, we worked to create this thing, and we actually failed on the first test, where we couldn't get it ignited because we just missed that narrow band where it was flammable. But then we did get it to ignite, and it was good to see the fire services response, because they know fires a lot better than I do. And, they said, yeah, that's a slow moving flame. We can understand that. And it actually, I think, helped them a lot understand what we were trying to say about low flammability refrigerants, what they really are.
What I would like to make a point of is what I've learned throughout this whole participating on these, committees and working with this, is that it doesn't take much movement of air to start mitigating the flammable refrigerants. You heard Bill talk about how everything had to be calm, because even just walking through the room could be enough to cause the movement of air enough to keep it from igniting. And as you notice on the slide, this was 4 or 5 more times the allowable charge limits that they had to use to get to this. So it's well, I'll stop.
Yeah.
Sorry, go ahead, Steve.
I say this obviously resulted in a lot of conversations and a lot of back and forth. And I think one of the important things here is the fire service typically doesn't get called because everything went right and every rule got followed and everything was installed to code and it was all done perfectly. Normally they're dealing with all kinds of different things. Some are hard to imagine how it wound up that way. So when the fire service hear things like, well, that can't happen, they start laughing because they've seen what seems to be the impossible happen. So the fact that everyone was able to kind of work through this exaggerated scenario, I think built some trust and some acknowledgement on both sides that we wish everything was following code all the time, but many times it might not be the case.
No, thank you, Steve. And I think, it was interesting to hear about this on the phone. I had really wished I was there to see this, but, hearing that first night when the team tried to run the first scenario and telling me that they couldn't get the darn thing to ignite, and that we had to go back in the next day and and do it all over again. A lot of work was done, I think, Dick and the technical team, calculating exactly the gradient of concentration on this. And I don't want to get too geeky about this. Probably folks on the phone aren't interested in all that, but it was a lot of work went into this. And I will tell you, this video is very interesting to me as a person who's not a professional in the fire service. I was really fascinated by the way that the fire moved and the refrigerant moved. It was a very, very interesting. And I think if for no other reason, I would watch this training just to see that video.
Yeah, I mean, it got to the point where even one of the UL engineers was running computer models overnight to figure out what height we had to put the igniter and how many different igniters that we could try so that we were sure to get an ignition. So it was a neat engineering problem to get it to go.
It was. Steve, thanks. I'm sorry to interrupt you. And it was a great conversation, though, so thank you.
Absolutely. Let's go to the next slide. So we talk about the technical component of this project, and the result of the technical component of the project is the technical report. It summarizes all the research work conducted by UL, and it was authored by research engineer George Hunter. It's important to acknowledge that the report is meant for technical audiences, particularly if an audience wants to know every little detail, wants to examine the context of the research, you want to dig into every single measurement, you want to look at hundreds of graphs, or ultimately if you want to replicate the research or you want to build on the research. That is why the technical reports are so important. It adds to the body of knowledge that we have. All the experimental methodology, the detailed test results, all of that are in the report and organized, and it's all available on the AHRI website. If you go into their research report section, you can download the report. We also have this report available on the online training program. So there's a resources tab on the online training program, which I'll show you in a second, that allows you to get to the report very quickly if you want that technical detail behind the online training. Next slide. So here we are, online training. From the beginning, myself and our colleagues at UL FSRI knew the importance of getting whatever the information was that was going to come out to this to the ultimate stakeholder, which in this case was the fire service. And I mean, our experience working with the fire service tells us that they're an incredibly diverse group of people. They've got varying response areas, they've got varying interests, they've got varying challenges, and they're not always looking to read several hundred-page research reports. So what I'm really trying to say there is that we need to take the information and translate it for them and deliver it in a visual way. They're very visual learners. That tells them what they need to know with the option to dig deeper if they're compelled to do so. Not holding anything back, not hiding anything, all the information is there. And they want to know how it applies to their reality. And that's what we attempt to do with this online training program. And I'll always refer to it as really simplifying and applying the information for the fire service. It is by no means dumbing it down and will never be dumbing it down. It is simplifying and applying. Really one of the best tools that we've had since we've been doing research with the fire service is online training. We invest a lot of money into making sure that the science meets the streets. So actually, luckily enough, right before the pandemic, we did a big investment into our UL Fire Safety Academy, an online learning management system, free to the fire service, free to everybody, really. We launched it a little over a year ago as a free resource, and we've got well over 100,000 course certificates of completion issued since last January. So heavily used by the fire service. And this is one more course that we will add to that catalog, and hopefully we get a lot of eyes on it, because I think for the most part, the fire service as a whole hadn't seen refrigerants, any refrigerant for that matter, as what it means to their operations. Hopefully we can raise that visibility with this online training course. Next slide. So we want you to go take the course. So I'm not going to go to a ton of detail here, but the audience, as I mentioned, is the fire service. Other stakeholder groups can certainly benefit from the course, but obviously the meat of the course is tactical considerations for the fire service. It goes through all the scenarios, it goes into details, it shows videos, so all of that is there, even if you're not a fire service member. There's information about regulations and classification of refrigerants and things along those lines, which you'll find interesting as well. What we ultimately want is the fire service to consider as part and how they do their work and revise their standard operating guidelines. So there's a lot of information in here that's immediately actionable, that they can start a conversation at the kitchen table of the firehouse tonight and talk about how what they learned in this course might mean to their safety and their operations. The objectives of the course are that we want them to be able to describe the evolution of refrigerants and the characteristics of the substances found in residential and commercial refrigeration and air conditioning applications. We want them to compare the results of performance tests conducted on 3rd and 4th generation refrigerants. And we want the students to identify the hazards presented by flammable refrigerants and incorporate tactical considerations based on the experimental results into their standard operating guidelines to improve firefighter safety. Next slide. So how do you get there? Well, the course is accessible free via the UL-FSRI Fire Safety Academy. You've got to enter a few fields to create an account, but it's completely free. The course is laid out in modules that cover an introduction, like we talked about, classification of refrigerants, tactical considerations, and a summary and assessment. So in about 45 minutes, you can go through all the material. There's some optional material that you can dig into more detail should you want to. But in 45 minutes, you should be completing the quiz. And if you score well enough, you'll be issued a certificate of completion. And we hope that we get a whole lot of you and a whole lot of the fire service going to the website that's on the slide here and going through the course. Next slide.
So thanks, Steve. So just before I go to this and kind of wrap us up and move to the questions, I just wanted to say a special thank you to Angie Bennett. She took a huge stack of research and information around refrigerants and air conditioning, something that perhaps she didn't know very much about, and she condensed it and made it understandable. And put it in terms that that common language that we can all understand, as well as incorporating the tactical considerations and safety measures, to kind of keep the fire service safe. So, so I just wanted to give a special shout out and thank you to Angie for all the work that she did very, very quickly. And I've looked at some of these other courses that she's got that the folks at FSRI have posted on their site, and they really are fantastic. And if you haven't had a chance to look at that website, that's a great place and a great resource. So with that, we're going to turn our attention to the questions in a minute. But again, the way that this kind of puzzle fits together is the refrigerants and firefighter tactical considerations. The first project of its kind related to fire impinging and refrigerants and equipment any place in the world to provide practical information for first responders to develop training. In spite of all the other research that's been done, I think this puts this into the right context for first responders. So with that, we can go to the next slide, Mary. So as we noted, the fire service was looking for some data to be developed so that they could look at hazards specific to their needs to keep them safe, as Steve mentioned, in their workplace. Through this, that was completed through this collaborative effort between, fire service, equipment manufacturers, component manufacturers, and others, and UL especially. And then it's resulted in this online training. And again, I would watch that training, and I'm going to again just for scenario 5. But it's a great class, and I think that one of the things that we didn't really point out and stress. I think Bill and Kathy maybe made this point early on. There was from their point of view perspective, knowledge about the hazards related to refrigerants that are in use today is not always clear to people, and the training also provides that information. And so I wouldn't wait to take this class. I would go ahead and take it now, and as an opportunity to look at the hazards that are in existence today. So with that, I'm gonna. There's some questions from the participants. So I'm gonna start with one for Dick. Dick, this is a technical question that's gonna ask about which refrigerants were used, and then there's a question here about about somebody who apparently does training and wants to know what ratio of gas to air mixture that they should be thinking about, 13% or 23% or 27%. So I'm going to open that up to the fire service folks, but first I'm going to ask Dick about which refrigerants were used in the project.
Yeah, sure. So what we did is we tried to baseline 410A, which is the common refrigerant that's in most residential, light commercial, medium commercial units. So we ran a baseline with that. Then we ran 32, which is an A2L refrigerant, and we can talk more about that if there's more questions. We ran 454B and R466A. 454B is also an A2L, R466A is an A1. And so we ran these refrigerants trying to compare them. So, the thing was first to compare it to 410A, see if R32 and 454B look different. And, in some of the testing, we kind of made decisions that said, hey, 32 and 454B, they're very close to each other. Let's just focus on one refrigerant. So that was, again, kind of the collaboration we did, said, we're not going to see much difference. Let's just pick one of them and run it.
Thank you, Dick. So I don't know if Bill and Kathy could answer this question or not. It's not an answer that I know, but this question is, when I talked to our fire science class about this, I'm trying to remember the ratio of gas to air mixture. Was it 13% or 23% or 27%? Does anyone know? And I don't know the answer to that question, so I don't know if any of you do either, or if it's something we should get back to him about.
Well,
Really
Helen, I
think.
Sure, go ahead. I was going to say, I think they're talking about the lower flammability and the upper flammability limit. So you look at R32, it becomes flammable at 14.4% concentration and becomes unflammable at 29.3%. To give you a feel, you look at propane becomes flammable at about 2.1% concentration. So I think that's what they're asking, but maybe I got it wrong, Bill.
Bill, did you want to add anything to that or any concerns?
No, I was just going to say it depends on the product. We actually tested quite a few different products, and they all vary.
Yeah.
Oh, great. Okay, that's very helpful. And I think that's it's a tight range of flammability. At the upper edge of things, you run into this oxygen deprivation problem, and on top of the other issues that you have. So that's certainly a challenge. There's a
Helen, maybe one more thing to add is one thing that's kind of unique that people don't realize with the A2Ls. It takes relatively high concentrations to get flammable. So you need a lot of refrigerant in a very small space. There was a lot of concerns that these refrigerants are odorless and colorless, but when you release these amount of refrigerants, you actually can hear it, you can see it because it condenses all the moisture out of the air. So it's high concentrations.
Yep. Thank you, Dick. That's a great reminder. Thank you. I'm going to ask Kathy and Bill and Steve if they saw anything that was unexpected or surprising as far as refrigerant usage hazards. But first, I'm going to answer a couple of questions about from a regulatory perspective. So I'm going to turn back to you all here in a minute. This person is asking about the regulations in Washington states and 9 other states. I did want to clarify that. We anticipate the entire nation, because of the American Innovation and Manufacturing Act, the AIM Act, in 2025 will require these new refrigerants that are A2L, lower flammability refrigerants. We anticipate the entire country going to that in 2025. And then they're asking about, and Dick, I'm going to come back to you and ask you about this around the charge sizes that are allowed for these new refrigerants. I'm going to answer one more regulatory question, and then I'm going to pivot and ask about any unexpected results to Kathy and Bill and Steve. So another question from a regulatory perspective is, can an old refrigerant system be retrofit to the newer refrigerant, and is there a way to determine which refrigerant is used in a particular system? So the answer is you cannot. EPA does not allow you to change class of refrigerant. So if you are using the current A1 lowest flammability refrigerant, you can retrofit to a lowest flammability refrigerant if the manufacturer allows, but you can't go to a higher flammability class. It's not allowed. And refrigerant systems are labeled that with the refrigerant that it is contained in the system. So let me pivot back to Kathy and Bill and Steve to ask them if the tests yielded results that were unexpected or surprising as far as refrigerant usage hazards.
I had anticipated much more of a reaction with the fire, and we just didn't see it.
Yep.
It took a lot of work. Also, the refrigerants dissipate very quickly. Didn't anticipate that. I thought it was going to be pooling. I thought it'd be relatively easy to ignite, and none of that took place. I did not anticipate the hydrofluoric acid issues that arose during the testing. So once again, you can get that in the training portion when you watch that.
And again, I'll just say it again. It's exactly what Bill said. It just wasn't. There's no flashover. There's no explosion. It just wasn't what we were kind of fearful of seeing. And again, I'll say it again. It doesn't take much in mitigation. Just a fan or just walking or just something to disperse it enough to the point where it won't ignite. That's what really has surprised me throughout this whole thing, how little air movement it takes to mitigate it.
And I'll build on what Dick said. Dick had mentioned that while you have a leak and it condenses and it's odorless, colorless, but you can see it unless it's in a fire environment. And then if you've got smoke, you can't see anything. I guess I kind of expected an obvious hissing noise or a gas expansion noise and things like that. And certainly with the regular fire ground noise that would normally be there in the background, you may not know that it's taking place. So there's a lot that can be done from a fire service size up perspective and things like that from an ongoing safety operations, again, that are all in the online course to suggest what those might be.
Great, thank you, Steve. Kathy and Bill, Steve, I'm going to ask you this question from the participants in a minute here. First, I'm going to put Dick on the spot. So this question I'm going to give to you is, what impact does the hydrogen fluoride have on the life of the turnout gear? And does this change our decontamination procedures? Will this force more departments to purchase more gear to comply with clean cab requirements? Dick, before they answer that question around turnout gear, I'm going to ask you about the high concentrations. So since this is high concentrations, are we looking more at chillers or VRF in a high or large systems in a high rise as being a potential issue? So Dick, that one is going to be to you around the high concentrations. What kind of equipment are we going to be thinking about?
You want me to go first, or?
Yep.
Okay. All right. Yeah, as far as the HF, I mean, this is something that as an industry, we've been probably a little bit lax than we should be. You know, the current refrigerants, the A1 refrigerants we saw from this test make the same equivalent amount of HF when involved in a fire that an A2L does. And we just probably haven't done a good job educating our servicemen, educating our fire service people. If you look on an SDS sheet, it is there. So it's just a caution that you have to be aware of. And, it's something that I think the training material is going to reinforce, that things we should have been training on. And I think we've got to reinforce that in our own service practices, with our servicemen. So, I encourage not just the fire service people to watch these videos, get our service people also taking a look at them, because you'll learn some things as to what the FSRI guys have done in terms of educating on that. So I don't think it's really changed. It's just, I think we got to re-educate people and remind them.
Thank you, Dick. I'm going to ask Kathy and Bill and Steve around turnout gear and hydrogen fluoride, and does this change procedures and for decontamination, or will people need more gear? I don't know who'd like to maybe approach that first, Kathy or Bill or Steve.
Well, I'll hit that. We do address that in the course, so please go and see that. But the high level version is in all of our other research recently, as it pertains to cancer issues in the fire service and things along those lines, whether it's the PAHs, the VOCs, all the other chemicals that are in smoke anyway, the gross on-scene decon that we've recommended to reduce the chance of cancer, the same thing applies here. You want to dilute and you want to get that gross on-scene decon taking place in this environment as well. And then there's other things that you can do to limit that exposure also. But more details are in the course.
Kathy or Bill, anything that you would like to add, or?
I'd just like to say we didn't conduct any testing on turnout gear,
Mhm.
so I can't comment on that.
And it's important to know that the fire investigator that come in to do origin and cause, they should also be wearing PPE as well. It's important. I mean, I remember when I was doing origin and cause, what I wasn't wearing. So, I mean, that was 1,000 years ago, so.
I don't think so, Kathy. Dick, this one may be to you and to me, but there's a question here about the maximum amount of A2L refrigerant that can be stored and used in a building, and is there a proposed code change that would allow larger quantity?
Yeah, there's probably two answers to that. There's, the refrigerant that's in our equipment. So in our equipment, it depends on whether it's an indirect system or a direct system, and this gets into the UL 603352-40 standard, AHRI 15, AHRI 15.2 that's coming out. And Kathy was kind of hinting at it a little bit earlier. We like our terms, but, we've kind of defined these M1, M2, M3 terms that tells you how much charge you can have in a unit, where you need mitigation. So there's a lot of new things that the installers are going to have to do. They're going to have to look at the nameplate, what refrigerant's on it. They're going to have to check to make sure there's mitigation controls in the unit, and there's ways to check that. And then there's also things that they have to look at the area and the space. So that's the equipment. Then there's a requirement that's in the process, and Helen, you may be able to answer this one better than me, that was in the code approvals for the NFPA standards in terms of how much refrigerant we can store in a warehouse, that a distribution warehouse for servicing of refrigerants. And maybe, Helen, you have the latest number that just came out of the NFPA 70, I think, right?
Sure, yeah. No, I mean, I think there were some code change proposals submitted by the Fire Code Action Committee under the International Code Council, the ICC, to increase allowed storage, based on equivalencies. So they looked at kind of the properties of the lower flammability refrigerants, the A2Ls, versus, like a propane or others, and kind of compared and said, what would be comparative here, what would be equal. And so they're moving away from that 150-pound limit to be increased. And then, of course, with sprinklers, you're also able to increase the amount stored. So more to come on that, because that's not final yet, but we'll be glad to stay in touch with the person that sent this question around, as we see that evolve, and provide some additional details. So another question here was, after national rollout in 2025, when will the next transition be for refrigerants? So how long will the A2 era last? So that's probably Dick to you and me, and I'll tell you, I think that A2Ls are going to be around for a very, very long time. And Dick, I don't know if you have a different view on that, or if you would like to comment on that one.
Yeah, I've been around since the beginning of time, long time. And this is my fourth refrigerant transition. So, we're running out of options. And, one of the things we're looking at, most of the refrigerants, especially when you look at 410A, the likely candidates are going to have to be A2Ls. So, I think they're there to stay with us. What we're faced with is phase down requirements that are still evolving. Helen mentioned the AMAC that's been passed. The final details of that are still being rolled out, but it's generally going to comply with the Kigali Agreement, which has a step down phase out of refrigerants, or GWP, over time, ranging out to 2034. It'll depend a lot on how good our industry is in terms of managing reclaim and things like that. So, when we have to change the next phase down after 25 will depend a lot on the overall industry and how they go. And Helen, you may want to add a little more to that.
I think that's a good summary. I do want to, we're running out of time. There's a lot of good questions here. There's one about oil, Dick, that I'm going to ask you here in a minute. But before I get to that one, Steve and Bill, there was a question around whether the ignition point is on the vapor or the liquid side. When you saw, I guess, especially that scenario 5 run, you know, did the ignition occur on the vapor or the liquid side? If one of you would like to answer that one.
When it decompresses, it becomes a vapor. So you're not burning a liquid.
Great, thank you very much.
And also,
Bill.
I can answer the question real quick on the oil as well.
Okay.
We burned actual refrigeration units. So it wasn't just a line with the product itself, it was the actual refrigeration unit in the room, and we burned that, and the coils melted down, and it was released. So it is real world.
Thank you. Dick, my question to you, there's a question here about whether or not oil was included with the, you know, the current refrigerants and with the future A2L refrigerants. Was oil in the mixture in the testing?
It wasn't for this testing. This testing we did with pure refrigerants. In some of the other research that Helen showed on that chart, we have done testing with refrigerants and oil, found the oil has really no impact because it's at such a low quantity. It's at 1 to 2% in circulation when we're running our units. So, but you know, we can, in some of the prior testing, some of the AHRI research reports, you can find further details on that.
Yeah, so the person that asked the question around the oil, we'll be happy to send you a link to those other reports and some additional information about research that has been done around refrigerants containing oil. You know, we're running out of time. I do want to thank everybody, but first I want to ask, I'm going to ask each one of you if you have anything else that you'd like to add. I'm going to add a plug to go watch the training at the end of this, but if there's anything that each one of you would like to add, I'll start with Dick, and then Bill and Kathy and Steve in that order. So Dick, is there anything else that you'd like to add or?
No, I just thought this was a great way to do a project. I mean, it took us a while to get to the tests we wanted to run. You know, there's a lot of opinions on both sides of the streets, but I think it worked out really well. And even though we had the pandemic going on, it was well worth the trip to Chicago multiple times to really watch the fires, make changes on the fly, work as a team. And I'd encourage us as an industry to spend a lot more time on this stuff with fire services and other groups. And, you know, it's the way to really get projects done, is to really collaborate on the stuff.
I agree with Dick. It was a great project. There wasn't always agreeance on everything that we were doing, and there was a lot of spirited discussion, but I think the end product is fantastic. So thank you.
Kathy, is there anything you'd like to add?
Just, I agree completely with what everybody has said. This was just really a great project, and really a lot of very good collaboration. And thank you, everybody.
Yeah,
But I want to emphasize, thanks to the UL team. They worked many long hours into the evening to get these tests done, and in the month and a half that we were there. So I really want to appreciate the UL team in Chicago.
Appreciate it, Dick. Yeah, I mean, it took an army to get this done, and pleasure to work with everybody. We got probably more work to do, but ulfirefightersafety.org, I put it in the chat there. That's the website to go to. Click on training, and that'll take you to the Fire Safety Academy where you can take the class.
And I'll just say it only takes about 45 minutes. The quiz is great at the end. It's only 10 questions, and if you've listened to the training, you'll know the answers immediately. And if you don't want to take the quiz, then you'll at least have seen all the very interesting training and videos involved in it. I did want to say thank you to everyone, and again, thank you to Angie Bennett and George Hunter, who wrote the reports, and Angie, who developed the training program, and the other folks at UL, as well as FSRI. And thank you to Kathy and Bill and the other folks from the fire service that were involved with the project. We really, really appreciate it. Folks, if we didn't answer your questions, we're going to pick these up, and we'll send an answer to you. Mary, if you could go to the last slide. we will post these slides online as well as a link to this webinar. So if you missed something and you want to go back and listen again or point somebody else to it, it'll be there. And there is a slide here at the end if you want to contact Mary or me, and we'd be happy to try to help you out with anything that we can. And we will be trying to send answers back to folks that had questions. So thank you all very much. We really appreciate it, and we were happy that you all spent an hour with us today.